Okay, we continue with the rotational equilibrium. So,
Focus.
let's consider.
Like and subscribe.
Let's consider the next situation. We have a bridge with the supports at the end, and the mass of the bridge will be 200 tons. 200 tons, which is 2 times 10 in the power of 5 kilograms. And we have two car and a truck on the bridge. We have a truck here. And we have a car here.
Alright, what's the mass of?
Mass, that is a mass of the bridge. Mass of the truck will be, let's say, 10 tons. So equals 1 times 10 in the power of 4 kilograms. And mass of the car will be 1 ton. So will be equal 1 times 10 in the power of 3 kilograms. The length of the bridge, let's say 50 meters. The distance from that will be support A, that is support B. Distance from the truck to support B, let's say 10 meters. And the distance from the car to the support A, let's say will be 20 meters. Question is, what is the normal reaction at each of the support? So what is the normal reaction at the support A and support B? To do that, first we need to consider at point A, at the pivotal point. That rotation, we can see the rotation about this point. So what's rotating this? We have mass of the truck, G, we have mass of the car, G, and we have also mass of the bridge, times G. And we have here, we have normal reaction at A, normal reaction at B. So which forces will try to rotate bridge around point A clockwise?
The truck.
Truck,
The bridge.
weight of the bridge, and the car. What's trying to rotate it anti-clockwise?
The same things.
Anti-clockwise reaction, normal reaction at B. These three try rotate it this way, and these try to rotate in the opposite way.
Oh, are we talking about B?
It at B. First, if this is point A. This is point A, and normal reaction at B acting upwards. In which direction it's rotating?
Anti-clockwise.
Anti-clockwise. Because it is in the equilibrium, then the sum of the torques clockwise has to be equal sum of the torques anti-clockwise. So let's write the torques rotating it clockwise around point A. So this one we have 2 times 10 in the power of 5 G. What will be the lever arm, so distance from A to the truck?
Now what's 2 times 10 to the 5 G?
It's a mass of the sorry, that's mass of the bridge. Mass of the truck is 1 times 10 in the power of 4 times G times what the lever arm to the truck. What the distance from A to the truck.
50 meters.
This is 50, this 10, so it's 40. Plus bridge, weight of the bridge, we have 2 times 10 in the power of 5G times what will be, we consider that all mass of the bridge is at its center. So what will be the lever arm?
25.
25 times 25 plus car, we have 1 times 10 in the power of 4G times
Power 3.
to the power of 3, car in the power of 3. And what the lever arm for the car?
20.
20 meters times 20. And that's equal the torque rotating anti-clockwise. So NB times 50. So this distance is 50. From here we just need to do some arithmetic. Let's take G, for simplicity's sake, let's take it as 10. So we will have, this is 4 times 10 in the power of 5, plus we have
Isn't that 4 times 10 to the 6?
6, yes, good, following.
He's tricking us.
Plus, we will have that will be 50, so 5 times 10 in the power of 7. And we have plus 10 in the power of 4, 2 times 10 in the power of 5. Equal 50 and B. Adding those. Add them. I want me to calculate
5,
everything.
4, 2.
Just do it in your head.
5, 2,
No, 5, 4, 2.
yes, 5, 4, 2.
No, but you got divided by 50.
No,
5,
it
4,
says
2,
to add them.
add them and,
Yeah, 5 zeros.
and 5, 0.
Times 10 to the power of 5.
Equal 50 and B, yes.
What's 50? NB times 50.
That is the torque of the normal reaction at the point B, which try to rotate it anti-clockwise. Then we just need to divide by 50,
1.
so it will be 1084, and we have, this is divided by 5, and we have 4 zeros, I think. Or three zeros, yes. So that is, that many newtons is the normal reaction at point B. In the same way, we can, to find normal reaction at the support A, what we need to do?
Do the same thing as for the others.
We need to do the same thing, but considering rotation around point B. Then we will have that those 3 weight forces will rotate in anti-clockwise and normal reaction at A clockwise, and then equalize. Make sense?
Yeah.
Okay, another example. Another example we'll do from your booklet. And another example, we will look into the question.
We didn't work out the normal.
We'll look question page.
Mr. Bay, we never worked out the normal of A.
You can do it by yourself. Yep.
Did you just say to do A is just like the same, like do the same?
But we consider rotation around point B. Yes. Now, page.
We back?
Final. All in.
Page 67, page 67, question 23. Page, page 67, but we'll do question 21.
101.
Question 21. So we have the next situation. We have a beam that's supported.
It's a thing.
A string considered enormous and attached. So
It was, I don't know.
that is the situation. We have mass of the beam is 50 grams, equal 50 grams, that is 0.05 kilogram, and this angle is 30 degrees. And we need the length of the beam 0.8 meters, and the distance where the string attached to the beam to support it, 0.4 meters. And we need to find tension in the string. Which forces acting on the beam?
Gravity.
We have gravity, weight force. We have 0.05 G. And we have a tension acting this way.
Isn't
No.
tension both ways? I like the top as well.
But at top acting on the wall. Tension, yes, will be and acting on the wall, but we can see the forces acting on the beam. And there are two forces, and what we will take this point X, point Z, point Y, around which point we will consider possible rotation of the beam. What we will take as a pivotal point? X.
Solid.
So what's rotating is the beam clockwise.
T. No, that's anti-clockwise. Gravity.
This force rotating it clockwise. This rotating it clockwise. So torque will be equal 0.05 G. What the lever arm?
0.4.
0.4. Distance of the force applied to the pivotal point times 0.4. What's rotating its anti-clockwise?
Tension.
Is all tension rotating its anti-clockwise? We need to resolve tension into remember, we were talking the force acting. If I apply force along the beam this way, will I produce any rotation?
No.
No. Only perpendicular component of the force produce rotation. So we need to resolve tension in two directions. This is a tension perpendicular and tension parallel to the beam. But tension parallel to the beam does not produce any torque. It does not produce any rotation. So only perpendicular component. And what it will be equal? If this is T, what T perpendicular will be equal? Soccer tour. Come on, basic trigonometry.
I was thinking
T
about
sine 30 degrees. T sine 30 degrees. T sine 30 degrees. Does everyone understand why it's T sine 30 degrees?
Yeah.
Okay, and then times lever arm, which will be same, 0.4. So 0.4 cancels out. And we have the tension equal 0.05 times, again I'm taking for simplicity's sake, GS10 divided by sine 30, and that will be equal 1 Newton. You can check my calculation using calculator. Yeah, check the calculation.
Yeah, that's right. Exactly.
Well,
These
carry
exact
on.
values.
Okay, that's all explanations.
I probably could. Yeah, exact values. Sine 30 is a half over 0.5.